In our previous discussion, at the end, I gave one slide for your thought process. There, one data was given. The data was melting point of sodium chloride is less than magnesium compound. Both are ionic, but why in the case of magnesium it was more? I think you are ready with the answer. Here, ionic compounds are formed by the oppositely charged ions. Okay, so when the charge is more, attraction is strong. Attraction is more. When the attraction is more, bond is strong. In the case of sodium chloride, sodium charge is 1 plus. Whereas in the case of magnesium compound, the charge of magnesium is 2 plus. So greater the charge, greater is the attraction. Greater the attraction, stronger is the bond. Stronger the bond, more energy required to break it. That's why melting point of magnesium compound was more than sodium chloride. So data speaks, okay. We have to find out the reason why it is more. So in the science, once we conduct some experiment, why it happens like this? That is the reason. That only we will conclude at the end, like that. Okay. So now today I welcome for the today's few more points on any compounds. Okay. Today's small topic is what about the properties only. Any compounds have high melting point. In order to melt a substance, their particles must be able to move, flow. I told you, in an ionic compound, the ions are fixed in a place and each ion forms ionic bonds with neighboring ions, resulting in a very strong structure. Okay, see, this is one ion, plus ion, minus ion. Okay, this minus ion will have attraction with the plus ion. This minus will have with the plus ion, cation. This cation with anion, anion with cation, with anion. See how much attractive force is there when you go for some sample here. So because of this strong coulombic force of attraction, they go for close packing. Okay, movements are restricted. It is like a doing the parade, sadhan. So you are not allowed to move. So when you are not allowed to move, then it is from distance it looks like as if a strong pack. So when it is a strong pack, then we require more energy to melt. Okay, so that's why they have high melting point. Now, this is regarding the conducting electricity. For something to conduct electricity, it must have something that can move and carry a charge. Why can they only conduct electricity when liquid? So with the diagram it is explained here. Okay, ions in solid state cannot move, not allowed. Okay, close pack. So movements are once again I'm repeating, restricted. When movements are restricted, charges will not flow. When the charges will not flow, no conduct of electricity. You see here, ions in the molten condition, liquid condition are allowed to move. See how much gap is there here. You compare this diagram with this diagram. Okay, so this diagram, movements are there here. When the movement is there, so where there is a movement, there is a life. So then they carry the charge. Okay, that's why ionic compounds carry charge given by the electric current. Okay, when they are in the liquid state or the molten state. That's why ionic compounds conduct electricity only in the aqueous condition or molten condition or in the liquid state or in the melted condition. Okay, you pass current in the sodium chloride powder, it will not conduct. The same sodium chloride powder is put in the water, then you pass the current, you see bulb starts glowing. Okay, now after this we'll go after understanding the properties of ionic compounds. Now we'll go to this chapter is about the metals and non-metals. So more we learn about the metals, less we learn about the non-metals. Okay, that's why non-metals we learn in the some other higher class. So under the metal chapter now, metals are very useful, no, in everyday life. Whether it is a small needle to a car or to a bridge. So we require metals in every walks of our life. So from the small things to the big things, we need metals help. Sometimes metals are for jewelry or metals for ornaments, metals for decoration, okay, metals for the alloys. So metals have got a lot of uses. So when metals have got a lot of uses, then why can't you prepare? Why can't we extract? What is extract? To take out. But the problem is where they are metals. So in the nature, metals are distributed in the atmosphere or in the hydrosphere or in the lithosphere. Lithosphere is what? Rocky area. Hydrosphere is what? Water. Atmosphere is what? In air. Okay. So in all the three spheres, elements are there. Elements are there in the metallic form. Elements are there in the non-metallic form. Okay. So this is called availability of metals in the nature, known as what? Abundancy. So metals are abundant in nature, but among the one which is more, which is lesser, that nature has already decided. So whatever is there in the nature, we are taking out. So this is a pie chart which will give about the idea, which is more, which is, see, oxygen 46.4 maximum. Why? Most of the metals occur in the oxide form, okay, in the earth crust, okay, hematite, dolomite, iron oxide, copper oxide, zinc oxide. So rocks are oxides only. Rocks are oxides, rocks are chlorides, rocks are sulfates. So most of the metals occur in the form of oxides. In the oxide, what is there? O is there. So it is the highest. Then comes silicon, sand. Sand is everywhere, mud, clay, sand. So second place. Then remaining part is all these. Okay, right. See, they occur like this. In the nature, metals occur in the rock form. See, silver rock, iron rock, tin rock, arsenic rock in the form of sulfur, mercury. No, the carbon, coal. We take out the coal, no, for the railway engine. So coal, it also occurs. But we discuss about the metals, not about the non-metals. Okay, right. But just sample I have given you. Now, occurrence of metals. Okay, metals occur in the native state as well as in the combined state. Okay. See, among the 70 plus metals, some are more reactive, some are less reactive, some are least reactive. This we learnt in the reactivity series. See, metals which are most reactive, can we expect that they should occur in the free state, in the single state? No, because they're reactive. They want to combine sodium, potassium, rubidium, cesium, magnesium, aluminum, iron. They are so reactive, we never found them in the free state, in the single state. They occur in the combined state. But whereas the bottom one in the reactor series, gold, platinum, they are least reactive, they don't react at all. So they occur as a free with some impurities in the earth crust, in the rocky area, in the lithosphere, they occur. Otherwise, most of the metals occur in the combined state, only few occurs in the free state. Gold, silver, platinum, because they are least reactive, they occur in the free state. In the combined state, many occur. Okay, see here, gold taken out from the gold industry, platinum. Okay, in Karnataka, very famous gold field is there, no? In Kolar gold field. On this, we made a movie, beautiful movie, KGF. Okay, so we are waiting for the part two. That means gold is very useful, right? So, right. So today we learned about what? Occurrence of metals. Tomorrow we learn after occurrence how to get the metals. Okay, right. Till then, have a nice time and bye, my dear students.